Hey everybody, Professor Ratajczyk here, and I thought it would be fun to update a new data set and do a walkthrough here. So I've got some data here, and if you're looking at this and you instantly know what it is, congratulations. Um, it is hockey data for a particular player, so an individual player, it's not a group of players summarized. And um, one point I want to make right off the bat is I know that many of you are not athletes, but on top of that, maybe you're not an athlete and you don't know anything about hockey. You don't care about hockey. You have no interest in caring about hockey, whatever. So the point I want to make is that is going to be very common in the field of business analytics or business in general. I mean, we all want our dream job, right? And our dream organization. But most people do not achieve that right off the bat. It takes more work than other things, probably, as well. So in my career, I certainly got to choose some of the things I got to work with, like government agencies and things. But there were certain spans of my career where I got into a great company, but when I was a little boy, did I envision I'd be working for that company? No, no. Did I envision I'd be studying the products that that company sells? No. Uh, that'd be amazing if I had predicted all of that as well. So the point is, take this for what it's worth as a lesson. That you're not going to be an expert on your company's data the moment you start working for them. So in this context, yeah, you might not understand some of these columns here. So that's a lesson that you'll have to learn is you might not know everything about your company, but you'll have to learn it. St. Mary's mission statement, awaken, nurture, and empower. So the awaken part, that's me telling you now that you're going to face things in life that you're not going to be comfortable with, familiar with, perhaps. That said, I've got a data dictionary here. So if this is the first time you've ever heard of data dictionary, maybe you didn't take 351 before this class, that simply means I've got all the variables here and I've got a definition for them. I might even have data type here. I don't have it in this file. But I might have like, oh, this is an integer. This is always a text field with a maximum of 30 characters in it, like a varchar if you've taken the 351 class. This is always a decimal. And then over here, what is allowed? Negative numbers are allowed, or they're not allowed, something to that effect. But quite simply here, I just have a two-column data dictionary for you here for the folks that need to learn a little bit more about these terms. So what can we do with this data set? We can do a lot with it, actually. We can do a count of the seasons. Obviously, we only have 9 rows here. We have 8 observations. So right off the bat, 8 observations. We don't call row 1 an observation. Those are your variables. So in a data set, those are your variables, not your observations. So don't be tricked by saying, oh, we have 9 rows of data. No, you have 9 rows in your spreadsheet, but not all of them are observations. Okay, so we could do a count here. Let's say we had a lot more data than our eyes can digest. We might use a count function. Something along those lines. I want you to be aware just right off the bat that there are different types of count functions. There's count, number of cells that contain numbers. So if I use this here, it's going to say 0, and you might say, Professor, the function doesn't work. It does. While you see these as numbers, they're actually categories. So think about different types of data, quantitative versus categorical. These are categorical. It's a category. A season like this is a category. And so we might want to use this one here. Counts the number of cells in a range that are not empty. Okay. So now we have 8. We have 8 rows that are not empty, so we know we have 8 seasons here. Very cool stuff. We can do the same thing here. It's going to give you the same answer. I mean, just look, if I were to delete this, it drops it down to 7. So pretty cool function there. Right off the bat, we got the count, and then we have the count A functions. Okay. Again, same thing here. But instead of that, let's do something cool here. Let's do a count if. So we're going to grab this range. Instead, we're going to be looking for the MIAC. Okay, very popular term. We have two seasons or two rows of observations belonging to the MIAC. So pretty cool stuff there. So now we rattled off the count if. Okay. Now, this is where we're going to start getting into some gray areas of what we might do with this data set. We could do things like the min, max, mean, which is actually the average function. So I'm going to use the word average here. Mode, and there's multiple modes, and median. We could do all those wonderful things. Now, we could also do things like standard deviation. Okay, we could do correlation, which I love, and you should learn to love that as well. Later on in the course, you'll learn other things like what's it mean when you do standard deviation divided by the mean, okay, or in this case, average, okay? That's one of my favorite formulas out there. It's coefficient of variation. Hopefully you'll learn to love it as well. There's other things that you can do too. These are the bread and butter that I want you to focus on there as well. So you can apply pretty much any of that. You can do an average. What is the average games played? Okay, and now I can do that. I can drag that all the way across, get some nice averages. I could do the same thing here. Instead of average, I could put max. So in any given season, what is the max games played? 54. Then I got 5 goals, 9 assists, total points. Maximum in any given season is 13. Remember the PIM, penalty infraction minutes. So we got 62 in one season, and over under is -1. Okay, so a lot of fun stuff here. What I'm going to ask you to do, require you to do, is make sure that you data ink this. So what that means is, if your audience looks at this sheet right now, they don't know what you did here. They don't, I mean, unless they click on each individual cell, but I'm going to tell you right now that the business user is dumb. Okay? For lack of a better term, the business user is dumb. Don't assume that they're all experts in Microsoft Excel and that they're going to look at each thing and be like, oh, okay, I see they did the max there. Oh, they did the count A. Huh, never heard of count A before. What is that? I've only heard of count. So assume that your audience doesn't know much about the work that you do or how you do it. Nor do they really want to know how you do it. They just want to have some good, clean information to make a decision. Okay, so I'm going to show you now one of my favorite functions, correlation, because it starts to get us further on the right side of the curve, so to speak. So a correlation, but instead, so that's the function. I'm going to do a correlation of games played to goals. Let's see what kind of relationship we have with this particular player with games played versus goals. So the correlation function, we're going to grab games played, comma, goals, and hit enter. Note that if I drag this all the way down, I'm going to get numbers for a while. See what happens here. Don't do this because the correlation function only needs one cell to do its work. It's not one of those things like we dragged across here or something like we do this, plus this, or we do this plus this and then we want to drag it down. That's not the situation we do with this correlation function, okay? So I don't want to see anybody dragging this down here. Now maybe if we're going to do a different one, such as correlation of games played to him, maybe, it would not be appropriate to drag across here, even though we can get some data, just because, we're doing games played to him, not G to A. So you do want to be cautious when you do this in the drag and drop here. My suggestion is don't, unless you know what you're doing and what you want to do, more importantly, don't rely on the drag across with a correlation function, unless you're an expert or advanced person that has some experience with this. Okay, so let's just go ahead. We'll do the correlation of games played to PIM. Okay, so here's where your statistics and data inc here. I'm just going to data inc this up, make it easier for the user to see this. So instead of having all those decimals, I just put in 2 decimals. So what you know about this is distance from 0 equals strength. Okay, a lot of students think, oh, the higher number is stronger. You're right, but what happens? Let's say we had a correlation of negative 0.83 for this. I would say this, many students would say this one here, positive number, is stronger, and you're wrong. It's the distance from 0, and technically this one has 1 decimal place of more strength away from 0. So that's what you need to consider. That's what you need to be thinking about, is that. Now, both of these happen to be very strong because it's about distance from 0, -1 to +1. On top of that, they're positive numbers. So they're strong because they're really close to 1 or -1. But they're very high too. So it's not like it's a 0.13 or a 0.27. You know, we've actually got some very nice numbers here. So there is a very strong and positive relationship between games played and games, or goals scored, which would make sense, right? The more you play, the more goals you should get. It's just like in baseball. The more at-bats you have, the more hits we could expect. Subject to, of course, and that's why this isn't an instant one, there's other factors, such as in baseball, you can go to at bat as much as you want, but if you're not swinging that ball, then you're not going to get a hit. Okay? But just like in hockey, you can play in the game as much as you want or as many games as possible in that season, but if you're a goalie, then you're very, very unlikely to get a goal. Okay? Likewise, if you're more of a defensive player, then you might not get that many goals either. It's not impossible, but you might not get as many goals. So that's why we might expect, well, of course, games played and goals, I should have a 1 here. I should have a perfect relationship. No, there are other factors that exist. Now, based on this lesson, I would like you to consider taking this to customer data. What do you know about customers and things that they purchase together or that we expect they purchase together? Or are there any behaviors or demographics or psychographics that you might be able to look at in a data set, such as age, perhaps? Older customers purchase XYZ products more often than customers of a different age group as well. So just kind of a mini lesson here of different elements that you might want to consider when you're exploring a data set for the first time.